it is a very good course. Thanks to Mohammed Zaman Bhai for offering this class. He is very experienced in cloud, and for 27 years he is in, from the beginning of cloud to up to here. So, and I'm pretty sure that all of you will enjoy his class. And also, we are offering few more classes in future related to cloud if Jaman Bhai give us time, because his time is very precious. But still, I hope that he will give us some time. And thank you once again for joining, and keep us give us the feedback that how the class is, and what kinds of class you want in future. And also we are keep trying to offer those cutting edge technology classes like cloud, big data, and all those. All are free, so try to join. And whatever you can to really help us, help this community, please help us too. Thank you. Jaman Bhai, back to you.
Okay, thanks, Tanvir Bhai. So I'm just going to summarize for 1 second. I started recording. Again, security is fundamentally based on 3 elements, which is, we call it CIA, which is confidentiality, integrity, and availability. I'll go much in depth with those 3. And just in a very broad level, we are trying to protect the information from unauthorized usage. And I gave you an example where you're going to see some of those breaches where the data breach happens. It's essential, most of the time it happens actually from our internal folks, meaning somebody who actually has authorized access, but they're using something they are not authorized. So there is unauthorized usage. So this is why I just wanted to make sure that we all understand one very important fact is that the security is all about protecting the information from unauthorized usage. There is fundamentally a lot of different definitions. If you go everywhere, you're going to find something. But I found out that in a broad sense, if we put this as a goal, protect the information from unauthorized usage, this actually covers the security truly very well. Okay, so what is the CIA? Let me touch on that very quickly. It's confidentially. I have to protect the confidentiality of the data when and how it requires, meaning that this data has to be confidential. It is possibly for me. And whoever is the right person, they should only have the access to it. If it's for public, that's it. Great, public should have access to it. If it is for a very few people, for IT folks only, they should have access to it. Is for the highest executives, they should have access to it. The financial data only should financial folks or the right financial folks should have access to it. So confidential is very, very important. It's mostly about authorized usage. Again, on the confidentiality side, integrity, protecting the data itself. Like the data that I get, is that the right data? This question get answered by the integrity, because did somebody messed up that data? Somebody injected something on it. Somebody took that data, modified, and sent it to something else to me. So that's the fundamental element of integrity. And the availability is that when I need the data, do I get access to that data? A lot of time we think security, we hear this phrase, security by obscurity. A lot of time what happens is that we don't have access to the data. Hey, I'm in the field, I actually need to do something, and I need this data. I am authorized person, and when I click on this button, I just don't have access to that data. So if I don't have availability to the data, that's really, really not good, because of the fact if I don't have access to the data, that's also an unauthorized usage, because I'm an authorized person, but I couldn't use that data. So when you think about the cloud, or regardless, but I think mostly applicable for cloud, you want to think about 7 various elements of it. One is users and devices, meaning the end portion of that. As a user, when I log in, how do I log in, and what do I do with it? As well as nowadays with IoT, these are a lot of system actually does the login, not the user, but the devices itself do the login. Are those things being controlled? You know, how am I controlling those things? Again, think about the CIA for all of these things. So am I giving the right people the right authority and the right place or right type of availability to those data points for users and devices? Connectivity. Can I provide that access, you know, properly? Is that going to come through internet? Is that going to come via a VPN? Is that going to come through a private networking? Would that have multiple, or we call it multi-factor authentication? Would that have biometrics? You know, what is the way the connectivity would gonna be happening? Most of the time when we talk about connectivity, we actually talk about the network itself, meaning that from one end to the other end, how am I connecting? You know, this is very, very important. You hear something called data in transit and data at rest, meaning if I'm protecting my data in transit, that's the piece. This is covered by connectivity. Data in transit protection comes with mostly with that connectivity element that I'm actually protecting. Right now we are using Zoom. Zoom provides end-to-end encryption, meaning that, I'll give you this example much more in detail, but meaning that when I'm talking and you're listening, nobody actually can inject in between and come between you and me. So this connectivity is protected via a secure socket layer or a sort of virtual private networking. The next thing is perimeter security. What is perimeter security? A lot of things when people are trying to come into it, there are protection beyond what I am doing, meaning that, yeah, okay, if people are inside, fantastic. They already had, you know, think about a building. They already had the building ID. They went inside the building. They showed the ID. They had access to the, from the security guards are over there, but, you know, they went in because they had access. That security guard, that building itself, that parking lot that I am actually entering into, and somebody, there is a guard there allowing my car to park, that's a perimeter security. The building itself, physical facility, when I go in, the gate itself, the camera, and the guard who I give the card to, and or I register as a visitor, these are all you can think about physically perimeter security. In digital world, when I try to log into it, do I have a firewall? You know, that's a very starting point of perimeter security. Then you have intrusion detection system and intrusion protection system, vulnerability scanning, log management. I'll touch on those elements, but think about all those things that I have to cross, all the barriers that I have to pass before I can actually get into where I can access my data. So all those barriers that I have to pass, these are essentially the perimeter security elements. Then the infrastructure. Now I got into this. What kind of things that I have? In cloud, it's mostly virtual machine. Now, you know, virtual machine reside on top of something called hypervisor, which is on top of a physical host, like a server, you know, or like a, you know, a compute. So if we think about that infrastructure, how am I protecting that particular physical host? A lot of time, the host security starts at, if you just think for 1 second, at the BIOS level when I boot up the server. Because until, if the server is not connected, not powered, you know, it's fully secured. However, nobody can get into it and the server is not doing anything. So when I boot up, the first thing happens is that we touch the BIOS, or the chipset itself has to be secured. For a particular example on that one is that Intel has something called TXT, Trusted Execution Technology, that is embedded in the chipset that actually can compare if the BIOS has been compromised with. And you might have heard about Huawei issue. You might have heard about a Chinese manufactured processor that has been, you know, for DoD, for example, they actually have abandoned or discarded 10,000 physical hosts for that reason, meaning that if I could not validate the BIOS itself that it is not tampered with, I don't want to touch it because that's not a secure. However, typically when you go to a cloud service provider, they actually do take care of it. They make sure that the BIOS has not been tampered with, which is very, very important. When you create a white box physical host, you don't deal with it. But when you actually have an enterprise grade physical server, they have this security built in. When you boot up, then you come into hypervisor. For example, in VMware, it's ESX or Zen or KVM. So you might have that hypervisor, and you have to protect that hypervisor. There are a bunch of different things you can do to for hypervisor protection, like obviously different tools for different hypervisor, but fundamentally hypervisor are becoming thinner and thinner because it's only provides you the services that you need. Before, it used to be much more bloated. It was much easier, not very easy, but easier to get into it. Now that because the services are so limited, it's very hard to get into the hypervisor itself unless you have physical access to that particular host. Meaning, you can connect, you can remote in, essentially remote boot to that particular system. So you start to protect those kind of stuff. So you got into the hypervisor. When the hypervisor boots up, then these hypervisors are controlled by a management element such as VCenter. VCenter in the VMware term. I'm using mostly VMware term right now because that's what broadly being used. I don't want to confuse everybody with all other terms, but similar to that, you have Zen Center and all other things in KVM as various actually management suite and tools. So that vCenter actually, what does it do? It creates the resource pool, all the physical hosts together, and creates a cluster of resource pool. I'm not talking about real application cluster from Oracle or anything else. Just in terms of physical host, become a cluster of resource pools. So that is being managed by vCenter. So you got to protect that vCenter. vCenter is typically a Windows server. Just think about that way. It's a virtual machine. It's a server itself running and managing all the physical hosts, connecting, providing IP addresses, making it a part of the things that people can run VM on top of it. It also manages the network and all the virtualization elements of it. So vCenter is a very important one. So typically, you put that vCenter in a management layer and provide additional perimeter security to control and manage that particular element. Okay. Then once you are done with the vCenter, right now at this moment, you go to a portal and start launching your VM like Amazon portal. You go to that portal. And if you guys know already, or you might not, Amazon is a custom version of Zen as a hypervisor. Azure is Hyper-V as a hypervisor they use. So everybody uses various type of hypervisor. So now beyond the hypervisor, it's a portal you go. Whatever that portal that you go in Amazon has a portal, Azure has a portal, Google has a portal. Or if you have a private cloud, you go to this. Typically, it's called vRealize automation, vRealize operation. So vRealize portal. Yeah, you can go and you start launching those various virtual machines and servers. So if you can imagine right now what I'm talking about, like various level of infrastructure before I can actually get to my virtual machine, which will have my operating system, my application, my databases, and all those things. So that's what I'm calling the fundamental infrastructure management, infrastructure elements. Beyond this physical host that makes the infrastructure, you obviously have network related items. You have to protect your core network, the switches, the routers, the firewalls, like load balancer. If anything physical elements that come in, you have to protect all of those infrastructure components. Now, the next thing is your applications and the operating systems and the databases. All those things I categorized as application that runs on top of the VM. So now you have to protect those things. Now you have, for example, antivirus for operating system, anti-malware. IDS or virtual IDS or IPS or intrusion detection system, intrusion protection system, as well as file integrity monitoring system. So these are all those pieces, very, very, very important, that you have to manage at the operating system level. And a lot of companies like McAfee and Symantec, and they came up with much, instead of like an antivirus only, they came up with a bundle security system nowadays, which is typically, for example, one is called Deep Security product. So Deep Security has antivirus, anti-malware, IDS, IPS, and integrity monitoring, file integrity or content integrity monitoring system, all of them together. So the VM, so that there is no virus can come in, no malware can come in, no, if you are trying to attack it multiple times, it gets protected, as well as if the content gets changed by unauthorized usage, you get notification for it. So and that's the operating system level element. So I'm gonna check if anybody is sending me a message. Okay. So the next thing right now, after that, it's the operating system layer I'm talking about. Now, within that application, now we have the application itself. For example, I want to run Microsoft Office. So there are Microsoft Office related patches. If there is a vulnerability gets come in, so you have to make sure that your patches are up to date for that application, as well as there are elements to secure that particular application. If it is an enterprise application, there are components to secure that one. So that's the application, just protection outside. You can think about the perimeter of the application. Now, when you go inside the application, you have to manage the users and the profiles, making sure that if you are just a regular user, you have just a regular access. If you are admin user, you have admin access. You are the one who can create the users. You are the one who can create the profile. So you have different type of access. If you are backing up, you have the backup user, and they need certain type of access. So obviously, you have the user-based management within that application. And again, this is beyond the users who are coming into the system, but it is connected the way we do it. Typically, it's called some sort of SOD, which is segregation of duty and all kind of stuff, that you have somebody who actually creates somebody who creates a strategy or a profile. They shouldn't be the one who's executing the strategy and the profile. So you get all kind of things that comes in for that particular application layer. Then you also have the database. Database has to be protected at the data layer, which is the next thing that I'm going to talk about in a moment. But the database also have, protect the database itself. If the services are being hacked, how do you manage those things? So again, you want to protect all those elements at that application layer. At the data layer, it's fundamentally protecting the data so that the data cannot be accessed by unauthorized users. This is the most important part of it. If you think about that, all the things that we're doing, data is the king. And again, we're going to have a future course about data altogether. We talk about data in the cloud, because all the data, you don't own a lot of data nowadays. You connect to the data, you see the data, as well as you have your own intellectual property of the data. So data should be, and before I talked about data in transit, data at rest. So encryption of data at rest, that becomes very important. So for example, in this particular case, you have like Vormetric, you have a bunch of different things. You can do data masking. You can do data encryption as a whole. You can do field level encryption. Masking means that you're not encrypting it, you're just providing XXXXX for some of the data elements. You are encrypting at a field level, meaning that when you go to the database, yeah, you can see the name, but you can see the address, but you'd not be able to see the social security number. I'm just encrypting that particular field. Why is that important? Because if you encrypt everything, a lot of impact, one of the biggest impact happen is that your data, your backup is typically done, just to give you a very quick example, this is very important for data too. Backup is typically done is, I do a full backup, meaning the the whole environment, all the VMs, all the servers, all the applications, all of it, I backed it up. Then I do incremental backup. So a little bit of whatever change happened. Now, typically applications don't change a lot. Typically operating system don't change a lot. So we understand that very good. Typically the biggest size of the storage is your data. So if I encrypt the data, meaning that nobody can see it, so the backup agent, backup user would not be able to see the data. And it changed because even one bit changed, because the nature of the encryption, that everything is brand new. So every time I'm doing a little bit of incremental backup, I'm actually backing up the whole thing because I don't know which changed because it's encrypted. So, and in my set of eyes, or that particular tool, when it's looking at it, it's going to look at in such a way that the whole thing has changed. So if we do a third-party encryption, that's what happened. Obviously, within backup, you have encryption. If it is native to backup encryption, that actually knows the data, what changed, because it has the key, it encrypts, it sees the changes, and it only backs up the change. So the data itself, we're going to have a different conversation for a whole lot of different things. But I wanted to give you an idea of the key elements of data and the security portion of that particular piece, what you need to think about. Then the last thing, which is very important, is the auditability. This is where all those, we call it a GRC or governance, risk, and compliance, all those pieces come into play. For example, there are very stringent regulation. California has like SB 1386. What it means that if this is a personally identifiable elements and we had a breach, you have to do a very disclosure. You have to notify every single California citizen that something happened. Now, GDPR is the same thing. You have to, GDPR is the European regulation for privacy of the data. So just think about what happened in GDPR, why people are talking about GDPR, because you are liable for 4%, if something happened with the data that as a one single European Union citizen, and you have not taken the due diligence to protect that, as long as if you cannot prove that, you are liable for 4% of your gross revenue, your annual revenue, meaning if I have $1 billion, I'm responsible for $400 million. Whatever, the 4%, $400 million worth of my 400 would be, hold on, that's 40%, is that right? $4 million would be my fine, up to $4 million, as well as I have, I believe, up to 10 million. So there is a huge amount of financial penalty. What happens in others, like SOX? I'll give you the GDPR data. I'm just, jet lagged a little bit, but this is what it is. It's a 4% of annual revenue. That's the rule. And you are penalized for it. Huge amount of money. So people really take a lot of care to protect the data. Second thing is SOX. For example, Sarbanes-Oxley. What happens is that you have to protect your financials so that nobody can tamper with the financials. So what does it mean? If something goes wrong, it happened, the regulation was there, but the penalty started to being enforced, after that Enron issue, after the WorldCom issue, Lehman Brothers and all those things. So if somebody is falsifying that financial report, meaning that if somebody has access to that financial reports, and changing it or modifying it, that's for that SOX, the chief CEO, chief executive officer, as well as CFO. So the highest level authority, they would go to jail for it. So financial penalty is one piece of it. Then imprisonment is the second piece of it. So there are a huge amount of regulations. PCI, Payment Card Industries Data Security Standard. So if you think about that particular things, there are controls. There are 12 controls for that one. And if you miss a control And when you go through an audit, meaning they give you a plan of action, POAM, plan of action and mitigation, what it means by that, okay, I should have all these controls, and if I miss that one, I am not able to process any of my credit cards anymore. So this is very important too. And we need to make sure that everything is auditable. Meaning, if you don't know, you might know this, if you're a key person in IT or key personnel in various organizations, you forcefully take 2 weeks straight vacation so that even if you leave, nobody can actually be impacted because of the system is set up with that segregation of duty. So a lot of different regulations came in for that auditability. So these 7 pieces, I spent a little extra time. I want to make sure that everybody is very clear. These are the 7 pieces that you're going to think about when it comes to cloud security. I also did provide it on the right-hand side. You see the ecosystem, various organization, firewalls and IPS and vulnerability access like Qualys, Tenable, and those kind of stuff, antivirus. Some of those things, as well as application, data security, GRC, orchestration, some of those logos and things, and I provided a link. So you guys can actually go in and read up on those things a little bit more if you like to. But again, you have to think about, in a broad sense, think how you would protect your very own things. If it's my home, I want to protect my family. How do I do these things? I actually, almost go through all these 7 different items, So similar way, the organizations are doing the same thing. And they want you to protect everything that you do, everything that you touch. Now, let's go a little bit more detail. Is that right? Users and devices. Now I want to protect. How do I do these things? Typically, I would love to have a single sign-on. Everybody would love to have it because it makes it very, very, very easy. Very, very, very easy. So what does it mean? Meaning with a single sign-on, when I log in, I use my same credential, exact same thing for everything. Single sign-on is very tough to manage. So this is a big job opportunity to manage that SSO. A lot of different organizations offers it, like RSA offers it, as well as IBM. Everybody has a product for, not everybody, quite a bit of Microsoft has product for single sign-on. They have it, as well as federated Active Directory, because typically people started to use Active Directory or LDAP for managing the users and devices. So that's a very, very important piece. Or in a cloud term, a lot of cloud term, you're going to see identity and access management, which is IAM, IDM. So that's also very, very important thing. So if you think that you want to know a little bit more from users and devices, you might want to read up on those things. Remember, a lot of time there is a third-party contractor or people started to come in. So it's not very simple to manage. Also, another thing happens, mergers and acquisition in the enterprise world. Organization gets joined with another one, as well as organization is separated. Also, you need to give a third party. You just gave somebody an award, a federal agency, then you actually connect the users, you create those users, or you just connect to their Active Directory. There are a bunch of different things you can do. A lot of cloud already has this Active Directory built in. Managing Active Directory is not very easy. For a small organization, maybe, but for a larger and larger you get, it becomes more and more complex. Okay, next thing, connectivity, which is protecting the network. Is that private? Okay, if it is private, do I need to actually have encryption? Do I need to have something called, for example, I'll give you a quick one of BGP, which is Border Gateway Protocol. This is how you share the network routing between 2 organizations. Okay, it's great, I'm sharing it, but I really want to protect it. I want to know, this is very fast thing. I just wanted to have, they call it MD5 hash. And if you guys come from application side, you're very familiar with it. For the route, when I share the route, I want to make sure that I got the right route so that if the hash matches, then I know it because it's a one-way encryption. So that's something that you wanted to keep in mind, okay? Making sure, is that going to be private or is that going to be public? If it is private, how am I doing it? How am I sharing the routes, okay? If it is public, what are the keys am I, data in transit, what are the keys that am I using to protect the data? Remember, in private, people don't typically think about the data in transit encryption, but in public, definitely people do. Is that going to be an IPVPN? Is that going to be an SSL? What am I doing? All kind of keys and encryption pieces to it. More and more people are going towards software-defined networking, okay? Because what's happening is that, hey, this is becoming completely unmanageable. There's so many endpoints, so many different things. IoT is coming, and IIoT, industrial stuff. So if you think about some of the cars nowadays, they have more than a few thousand amount of sensors, each one of the cars. So how do I manage each one of those endpoints and the connectivity back to it? So it's becoming more or less software defined, and you just connect through an API, and it gives you a one-way token. That's how you encrypt, and in a certain, maybe every 30 days or every 60 days or every 90 days, you reissue the token, make sure that everybody is good. So that's another piece. Then it comes with traditional or cloud exchanges. Traditional things are meaning that network like MPLS, okay, for example, or I connect with something, mostly MPLS and point-to-point circuits, frame relay, and those things are gone nowadays. But if that is that a way that I'm connecting to the cloud, you can. Most cloud would allow you to do that. Or cloud exchanges are becoming more and more important, such as Equinix has something called ECX. That's the most popular Equinix cloud exchange. In terms of Verizon, it has something called SCI, Verizon Secure Cloud Interconnect. AT&T has something called NetBond. And these are the cloud exchanges. So what happens is that I don't have to connect to all those things. I just connect to the cloud exchange, and then I have access to everything. And again, you just need to think about that. Am I protecting the data that is moving, meaning data in transit protection? Perimeter security wise, it's very traditional. A lot of people are very familiar with it. However, there are things to consider, okay? VRF is called virtual routing and forwarding. It's a table that it tells you, okay, if you are trying to reach this one, use this to go there, okay? So again, wherever you are, VRF, now it's very much used in cloud world, as well as VLAN, virtual local area network, which means that, okay, I want to, even within my organization, even within my VMs, I want to have my production VM separated from my non-production, and I want to put it in separate VLAN so that, it doesn't touch each other or it doesn't impact each other. Then obviously the firewalls are very important. Okay, whenever somebody comes in, I create a rule. Typically firewalls nowadays are layer 7 oriented or application. So it does do in-depth inspection of the packet. So what used to happen is that there is HTTP, which is come through port 80, or HTTPS come through 443. These are the ports that you actually connect in, coming in. But the packet itself, the nature of the packet could be an SMB packet, or could be a data, could be a SQL procedure kind of execution, or some other thing inside the packet. So if you do a layer 3 or 4, when I'm talking about layers, I'm talking about OSI layers. There are 7 layers in OSI. So you go to this 3 or 4, this only sees the port and protocol. That's it. It doesn't go deep and does that deep packet inspection of, hey, you told me it's an HTTP packet. Are you really an HTTP packet or HTTPS packet? Most of the time, it used to be not those things when somebody's trying to attack you. So now layer 7 firewall like Checkpoint and the Cisco firewalls and other firewalls, that they go check the packet if it tells you I'm coming as HTTP, and if it is an HTTP, otherwise it just blocks it. So that's why the newer firewalls are much more intelligent. IDS is intrusion detection system, which means it's kind of like a camera. I'm looking at it, what's going through, and I'm analyzing what's going through. I'm not taking any action, but I'm notifying you that, hey, these kind of things are coming in. Some of the people are coming in, look suspicious, or everybody is good, or I create a benchmark of my traffic. So IDS is very important. It passes through, even if it is a bad thing, it passes through, but it notifies. IPS, intrusion protection system, actually is protect that guy. You know, it's kind of like a security force comes in and takes him apart. A lot of time, why people still use IDS, you might ask. IDS is being still used because of the fact that a lot of people, when they come in, they actually come in a valid packet, but I have not seen before. So it looks suspicious. However, because this application rapidly changing, and that's why I want to know before I start attacking that person. So, you know, we know that very well. If somebody dresses differently, then everybody thinks that person is different, but that could be a very valid person, you know. So we don't want to attack them. We don't want to block the traffic, because that would be a legitimate business. That's why IDS is still in use. IPS is very rarely used, in my opinion. That's what I see. That's how it should be anyway. I want to know what's wrong, and I want to take an action. I don't want that to be automated. So that's the difference between IDS and IPS. Log management, meaning that's a very important thing, that whenever something going through, I want to see whatever the changes happen, all the logs are in one place. Log management applies to a lot of other things, but in network pieces, I want to collect all the logs, make sure that I have everything. Vulnerability scanning is very important, because I want to know every equipment that I have, every code that I have, nothing is vulnerable in that code, because this is important for zero-day attack. This is important for known vulnerabilities, so that what happens if something is wrong. Vulnerability scanning mostly applies if something is wrong. Like, I give you an example. Cisco came up with a update for the router, and I have not applied, or I didn't put that patch. As vulnerability scanning would find it, and it let me know, hey, your Cisco device is not up to date. You know, it does vulnerability scanning. Log management applies for other stuff. Same thing. It could be like, oh, hey, Windows server you have, and you didn't apply the patch. Red Hat server, you didn't apply the patch. Or you have SAP, you didn't apply the patch. So, you know, it does all of those scanning of it and provides you. DDoS mitigation is distributed denial of services. A lot of people are trying to come in, and if they're trying to protect, it's unauthorized, they're trying to attack. Sometimes it feels like, remember at healthcare.gov, when the first time it came in, it crashed. A lot of people are trying to come in, and they didn't think about it properly. So that could be genuine. But continuously, all the banks typically get continuous DDoS attack. So that it creates something called honeypot. If it is a bad traffic, it collect all the bad so they can analyze it, as well as if it is a bad traffic, it can be protected before even it comes to you. Honeypotting means that you are allowing the traffic to come in, and DDoS mitigation actually would do most of the time with like AT&T or Verizon or Sprint or anybody who provides the network. At the network layer, they would just clean it up so that you have always legitimate traffic coming in. Infrastructure protection, I touched on that quite a bit. I will just touch on only a few things, which is storage. You gotta protect the storage. Nowadays, most storage is automatically encrypted, so that you cannot actually take that storage out, the disk, and come home and plug in the disk. You don't see anything. You can't retrieve anything. It has to be part of that same storage array that you had in the back. Also, in the cloud, you always have high availability, meaning if the VM goes down, there's another VM always available. You have backup copies. You have disaster recovery. Everything goes down. Actually, let me explain this thing. Let me spend a minute. What is the difference between high availability, backup, and DR? As a technical person, you should know the difference. High availability means that I have high availability in the same data center, technically speaking. If one of my VM goes down, one of server goes down, the second server automatically comes up and picks it up. High availability could be both of the servers up. If one goes down, another one is taking all the traffic. High availability also means that in the VM level high availability, physically it goes down, the server crashed, then it rebooted the other server. That's also high available. That has a little bit of time lag, but like in terms of OS clustering, when you do OS clustering, both of the servers are up. If one goes down, other picks it up. That's high availability. Backup is I actually make a copy of it, copy of the data, and typically at night. And for the logs, maybe every half an hour, every 1 hour for database logs. But everything else, I typically back up at night. So there's only one copy I have for every day. Okay, high availability, the infrastructure itself is replicated in same data center. Backup, made a copy of it and keeping that copy. DR or disaster recovery. Disaster recovery is that I have a full copy every 5 minutes or every 10 minutes in a secondary data center. That is the disaster recovery thing. So high availability, backup, and DR you should know in very well as a technical person. Typically, infrastructure is monitored by a security operations center for security events, network operations center for network event. Why security and network is different? That let me just tell you that security makes sure that authorized people get access. Network make sure that network is smooth. Anybody comes in, they can come in. So in analogical way, if you think about it, it's a road with a toll. Like you guys in Dallas, is that right? If you wanna Washington, Dallas, if you wanna go to that airport, you just jump on the toll road and go to the airport. So that toll is security. Road itself is network. So that's how you wanna think about network. Make sure that everybody can go. The toll protects who can go where. That's the security piece. Application, make sure the code is right. Make sure every SDLC, you follow the SDLC. Every security and compliance from has to be approved and looked at by third party. Okay. Data. I talked about data quite a bit. I'm gonna pass that off, but again, remember it's encryption, masking, protection at rest, data protection in transit. Tokenize the data when you share with somebody versus giving them the data. You want to make sure the backup is done right. Backup is fully encrypted as well as archived, because if you guys understand this, like in a HIPAA, you have to protect the data. But in an hospital, when you have a child and one of the children passed away or died or had some sort of health issue that potentially could be recurring, you have to keep that data forever. You cannot just delete that data. So you have to archive that. In a cloud, it's much easier. Like you have in Amazon, you have something called Glacier. Just pay a penny for it versus like $1 per gigabyte, penny per gigabyte. So that just makes very easy in cloud side to do this stuff. Auditability, I touched on a few things, but one very important piece, if you guys want to know, CSSCCM, which is Cloud Security Alliance's Cloud Control Matrix, that's something that you definitely want to read up on if you really want to know security in the cloud, because it's a harmonized mapping of various regulations and controls into one piece of it, which is the CCM, I think version 4.1 right now out there. So that Cloud Control Matrix 4.1, and it comes from the CSA website, cloudsecurityalliance.org. I have all those things in the link later on. So if you think about architecture perspective, what happens, how do you actually structure it? So a few things to ask. What is that organization or whoever wants to go to cloud? How am I protecting? What is my recovery time objective, recovery point objective of the data? You separate that. On the left-hand side, you see internal zone and a DMZ. DMZ comes from the public network, which is internet, for example, or anybody third party would have access to. I have the front-end perimeter security system, which could be firewall, IDS, IPS, log management, vulnerability scanning, load balancer, like F5, all those things comes into front-end perimeter. I'm talking about the top left corner of that at this moment. I'm coming from left to right, just so you know. So that is the DMZ. And when you see there are two servers. One is protected because that has application, and another one is actually the web front end. So everybody can come into the web after you're, you pass the muster, I would say. Then you actually start accessing the data. Typically, the data gets attached to that application, which is protected in addition to that web server, and separated out in a VLAN. Remember, I talked about that. And that's your DMZ. You protect that. You actually put a hawk eye. You look at it very carefully. You back it up. Is that right? You still have to back up. So you have a backup zone to back up all of those things. Same way, then, now I need access to a SQL server. That's very important. Where do you put the SQL server? I don't put the SQL server in DMZ. I put it in internal zone. If you're connecting, your app server is actually connecting via a private IP, multiple NIC or network interface cards, or virtual NIC, one of the private IP address, so that people can come to that web server that you have, but they can't actually go through that firewall because of the fact you're connected in a secondary NIC with a private IP address, go through the firewall into the internal zone. So only, and that's a layer 7 firewall, so only maybe I need to go through a SQL port or a private port, 65,000 port, which is, when you go more than 65,000, this is a private, which is anybody can use, anybody can come up with. But if you go through anything lower than 64,000, these are all publicly available or well-known ports typically. So you come through that port and go to the database server, and the database server sits on the right-hand side, which is in internal zone. And the customer's network, for example, ECX, customer privately connect with this network. That's not public. So those networks are private coming into it. So if a customer admin comes in, they come in through that private network most of the time into that internal zone. They can manage everything from there on. S2S meaning site-to-site network, meaning that that is not from the public site for VPN, site-to-site VPN. So they come through that VPN, people into that particular zone. As well as there is a management zone. For AWS, they have their own management zone. Everybody has their own management zone. And those are not accessible by any, as a cloud, I'm consuming the cloud. I'm a cloud, I would say, user, or my organization uses the cloud at AWS. We are not going to have access to that management zone. Now, let me make sure that everybody understands RTO and RPO, recovery time objective and recovery point objective. Recovery time objective means that if my whole thing on the left-hand side, the whole data center goes down, what happens? Meaning, recovery time objective says, and it might say 4 hours. Within 4 hours, I'm going to have everything up and running in secondary data center. That's my time objective, to have everything up and running. Meaning amount of time it takes to bring the environment up. Okay, that's the recovery time objective. Recovery point objective, RPO, means that how much data did I lose? Because, okay, the synchronization is happening every 5 minutes from primary to secondary. That means that I am going to lose, before the next thing comes in, there are maximum time data I'm going to lose is 5 minutes worth of data. Again, just to make sure, recovery time objective, the time it takes to bring everything up. Point objective is that how often the data I'm securing into secondary data center. So if I lose data, I'm going to lose 5 minutes worth of data because I'm actually doing a SQL transaction, or I just made a payment, but at the time the disaster happened, but the data did not get copied to the secondary side, so that particular transaction is going to be lost. So that's the recovery point objective. So again, same thing, exact same thing. You have secondary data center. This is how you need to architect it as a cloud provider. It sounds simple, and I wanted to simplify it. A lot of time you try to read it, it's so complex that we don't even understand what the hell they're talking about. So I wanted to make sure that it's simplified, but you understand the complexities within it, so you can actually architect the security of it. I have a lot of things that I recorded and put it in from AWS and Azure side, that what are the security products and what does it mean, okay? So you can have AWS directory services, for example, this is an active directory, okay? And cloud directory, which is also directories to organizing, different elements of it. Storage, which is HSM, is that key management tool, essentially hardware security module to manage it. So there are two HSM, hierarchical security management, as well as the hardware security module. So just make sure that when you're talking about different acronyms, and you know what the right things are. Then you have data classification. Amazon has something called Macy. Hold on one second. I don't know if I put it in. I think I might have put it in, or I might not have. Amazon Macy is one of the very good sensitive data classification tool, meaning it's a machine learning tool. Actually, they do it themselves, and it's much easier to utilize. Okay, yes, I do have the Macy here, and there is a link to it, and you can go with. If you actually go to aws.amazon.com/products/security, you will see all of them. You click on the button, and it would actually take you there. Let me touch on WAF, Web Application Firewall, the last item that we have. If you're a PCI provider, meaning PCI, payment card industry, you're taking credit card and you're processing, you have to be processing credit card. If you use third party, it doesn't apply. But if you're processing credit card and keeping the credit card data, you need to have a WAF for your development environment. Essentially, it mitigates a lot of those things for you, at least for development environment, if not also for production environment, because production might be already protected. Okay, just to give you one quick tidbit. But again, you go through all this stuff. This would be very, very interesting to learn each of the things in detail. Azure has a less number of stuff, but it actually bundles multiple things. So that's a very interesting way of doing it. If you go to Security Center, it actually gives you management, end-to-end management of threat protection. You're gonna hear something called UTM, which is a Unified Threat Mitigation, or UTP, Unified Threat Protection. So Unified Threat Mitigation is becoming more and more prevalent nowadays, because of the fact instead of looking at one component, you want to look at everything together as a threat matrix, and you protect that. Okay, what is it happening? There are a bunch of different things. SANS provides some sort of report that gives you also, exposes you what are the things that actually should be and the way that it is happening right now in the world, rest of the world, and how do I protect myself? Meaning that I have not got hit with it yet. So, SANS could possibly give you a data points and that the vulnerabilities that could be coming in. Hey, it's in the Asia. Yes, it's happening in the US. It's kind of like give you a geo idea with a geo view, meaning that a geographic view. So a lot of good stuff, actually. Security is very exciting, really very exciting. It changes a lot. It also tells meaning that you got to read up on it. You have to be up to date on this all the time if you're on this. So there is a huge amount of cloud security related jobs. Typically, the higher side of the world is CISO, Chief Information Security Officer. Even though it's getting maturity, a lot of organizations still treats it very as another director level job, something like that. But it's getting much more exposure. Now, a lot of them are reporting directly to the CIOs or directly out of CIO and directly to the CFO. So you would know based on the organization security sensitivity where that CISO actually either Chief Information Security Officer or Chief Security Officer or CSO reports up to. Most of the government organization must have a CISO anyway, entities, and they have multiple of them, and just to make sure that they are covered, just and that is required, I think, by regulation. DPO, which is Data Protection Officer, that is a requirement for a GDPR when you have certain amount of revenue. And it varies country by country. In Germany, it's different versus rest of the EU, it's different. Okay, so you would see data protection officers if you have a European operations or a multinational organization with a European presence. because GDPR fine, as I told you, 4% or 20 million euros, you know, this is not a small amount, and that's why they have a data protection officer. I rather want to pay somebody $1 million or all in, fully burdened $1 million to protect myself, because it also tarnishes my branding and a lot of other things. Then in the mid-level, I would say the security engineer, architects, analysts, IT auditor, as well as information assurance managers, they are very important. Just so you know, it doesn't mean that they actually make less money than the left-hand side. Sometimes they might potentially make more money. And it depends on your, if you didn't have any security incident, boom, you get a bonus. And that bonus is pretty hefty nowadays. I started to see those things. Again, that's a very interesting one. And this is a traditional job, I would say. However, it has sensitivity to it, as well as you need to know new stuff. Actually, the right-hand job, in my opinion, is the right one. This is very niche. You need to some extent, you are certified. You have essentially a license to do stuff. NSX engineer, which is a software-defined networking with microsegmentation and provide security at the VM layer. So that's an infrastructure person, however, with a significant amount of security skills to it. Okay, as well as the architects and the experts. So if you, and the auditors, PCI expert provides all the controls for PCI. So if you look at those perspectives, I just wanted to make sure that you have an idea where the jobs are and the gaps, really the demands for this thing. And just look at skilled labor shortfall. There is 1.5 potentially million skilled labor shortfall. This is very interesting to see in security workforce study. So again, on the right-hand side, I gave you some skill gap. Where should I learn? What should I learn? This comes from ISACA. ISACA is an organization provides security certification. Okay, so with that, I wanted to give you one more things that I didn't touch on, which what certification do I take? And I didn't actually put it together. There is intentional. I started to put it together. It became so large and so huge. Just didn't want it to do it anymore. And what it is that it actually depends on what you want to do with the certification. Because if you are on the governance side, if you wanted to have a baseline security, maybe CISSP is absolutely the best one that you should have. Not that easy. I took the test in 1996, and it's 6-hour test, and you have the passing was about 8% people who take the test. So, not that easy test. It might be much easier because you have a lot of books. At that time we had to read up on 10 books, 6 books for the 6 domains, as well as for some other books. But it's very, very important. Remember last week we had a session on IAM, and there is 1/8 of that's 1/8 of the test. So which is SailPoint. It was a tool that we talked about last week. So CISSP in a broad sense. There is so many other things. CISA, Chief Information Security Auditors, and few others. So what I'm going to do, I intend to do, is that when we do another one on governance versus security. Security is talking about letting you know all the tools and where does it apply, what applies. I'll do another one on governance and ITSM and all others. Then I'll talk about actually what kind of certification that you should actually go after. Unless you guys have any question and we can answer that question. With that, I know that we're over a few minutes, but I wanted to finish at 10. I know we started a little late. But we still have up to 10:30. We still have about 17 minutes left. So I'm going to stop this one at this moment and open it up for anybody who has any question and go over that. Okay, so everybody is muted. If you want to speak, please make sure you unmute yourself, and then we can go from there. You can unmute yourself, or if you raise your hand, I will, unmute. So anybody else has any question? Oh, let me just go to chat window. Let me see if there is any question. I think something important. Generally, who perform the system vulnerability? So one question I have: generally, who perform the system vulnerability and pen testing? It is typically done by third party. Most of the time, just so you know, you can do it yourself. There are so many tools. Qualys is one of the tool. Internally speaking, you must do it. So one thing I should bring up is FedRAMP versus FISMA, and that actually sets the tone. FISMA is an ad hoc audit, meaning that I go in, I audit if you're FISMA compliant, and there are some things that I need to do. Great, I know at that moment. But the moment you left, then there could be vulnerabilities, there could be issues. So FedRAMP comes into play, and that talks about something called continuous monitoring versus that ad hoc audit. So continuous monitoring means that I am now responsible to provide fundamentally, if there is something wrong happens, I'll tell you that, okay, there is something wrong, then you can take advantage of it. So continuous monitoring became much important. So while you have the third parties doing vulnerability testing and pen testing, the third part, the organization, most of the organization are responsible themselves to let the auditors know or let the regulators know if there is something wrong. So they do a continuous pen testing and vulnerability testing assessment, vulnerability scanning and pen testing, two different things, just so you know. Vulnerability scanning, meaning it scans and it tells you what are you vulnerable for and actually gives you the link. Pen test tells you that I can come into that environment to some extent. So again, responsibility became more internal at this moment versus the external one. And external ones, you still need to do it for audit. Third party needs to come in and test, because sometimes internally speaking, you might get complacent and you might miss something. Always needs to be done. SOD, segregation of duties. One person who actually provides the policy, another person actually provides the execution of it. The next question is, what is the best way to prep for CISSP and CISA exam? How much is just book-based knowledge versus hands-on experience-based knowledge? CISA is a lot of book-based, you're right. And when I took CISA, it was, again, you need to know some of the elements, hands-on experience you need to have. But mostly it's reading up and learning all this stuff. So, go to ISACA website and they update it, and they wanted to make sure that you understand the controls. That is book-based. But tools, security tools, those are not book-based. Those are you need to know. So again, CISA is a lot more book-based, I would say. CISSP, huge amount of experience you needed. In fact, you pass both of the tests, I believe you need a sponsor. So if you guys are taking some of the tests, I do proctor CISSP myself for a few exams here, and I understand that. I've contributed some of the questions to CISSP, but again, both of those are mostly, it's not like Cisco, CCNA or MCSE, significantly less hands-on. However, having experience, CISSP, they tell you that you should have significant amount of experience, and I believe so. Some of those could be natural. CISA is a lot more book-based. I have a question regarding data encryption at rest and in transit. Does cloud takes care of it by default? No, it does not take cloud does not take care of it by default. It gives you all the tools that you can take care of it. When you can connect via an encryption, meaning that if you connect via SSL, you can go to Amazon website, and when you connect to Amazon website, you are connecting via SSL because that is taken care of. But when you create a VM, you actually have to include the certificate. You need to make sure only, and when you create that firewall policy, you only create the firewall policy with 443, no 80, or HTTPS, no HTTP. So those would be fundamentally something that you want to do. Again, nothing gets taken care of automatically in terms of security in the cloud. You're responsible for everything. You're architecting everything. All the tools are given to you. So that's very important. All the tools, you have all the tools, but you still have to do it. What are the popular ones? Typically in transit is a certificate-based SSL. So that's the important one. And encryption-wise, there is Gartner. Remember last time I talked about Gartner Forrester. There's a lot of different tools. Vormetric is typically at rest, very, very popular one. Vormetric is data at rest encryption-wise. In transit, it's SSL typically. At rest is Vormetric, but again, you guys let me know. You're in that, I'm in a broader architecture for cloud. I know the things that I do on a daily basis, but I am always open to learn. This is not, I don't know everything here. And looking forward from you guys, that if you guys want to, let us know what are you guys using, or what whatever you want to share with us. Okay, I think that's all in the chat. Let me see.
Assalamualaikum, Zaman bhai,
Yes.
and the audience. I don't know. I don't have the language to really say thank you to Zaman bhai. I know that you are extremely busy. You are traveling over the world, but still you are giving time to us. I am really grateful to you. And the team, it is really honor that Zaman bhai is taking class. He is really very high profile person. I just do not want to say more. You can really Google him and you will find him, but he is giving us time and we are really very happy. And so Zaman bhai will teach us a few more classes, but if any one of you have specific interest, you can really let me know. We'll see that can he really make time. And thank you for joining us. And we are, as I said, that we are offering all these classes are free. And Zaman bhai also really helping us. It is just for Hasana, nothing else, just to help our community, to inform our community. This is it. And ITPF, as you know that now it is a 3,000 plus professionals network. It is one of the large community network here. And we placed last year we placed 18 people from our network. This year also a lot of people going through final interviews and stuff like that. They gave me update and we are helping. So those who have jobs, you are working, please go to your HR for 5 minutes, see that what is available, or ask your PM what is available, what kinds of skill set they're looking for, and just post. It's 5 minutes to 10 minutes and it's do it for Hasana, nothing else. Just we don't do anything for any return. Thank you. Back to you, Zaman bhai. Thank you.
No, thank you very, very much. It's absolutely my pleasure to do these things. I think all of us together, we can raise our community, make it a better one. So let's do that. And I thank all of you guys to make time on Saturday morning to begin with and to be with us. With that, I am done. I will stop recording unless you guys have any question. And you can again unmute. I muted everybody anyway. So, but hopefully it was helpful for all of you guys, understood. And I wanted to keep it not to the deep level, because I'm sure you can learn it. I wanted to make sure that you guys are on the train and you're going to the destination. Thank you very much.
John, but one last thing that what will be, do you think that we should really offer one more in security, or we can go to the migration?
I mean, I was thinking about going to migration. Now that you understand the security pieces, we can do another thing. We can do actually a governance piece, which is also very important. Like, for example, IT service management in the cloud. Again, there could be a lot of expert for that one, for ITSM. There could be a lot of expert for compliances. And I just touched the compliances, but there is a bigger things to talk about. We can do this. I was thinking about just to doing the next one is that migration, cloud migration. What are the things to think about? And again, you guys, we can decide together, or if you want, just send a message. Tanvir bhai, you're the one. You're the right one. We can also
just the reason I was really saying that then team will know that what is coming. So next one will be in migration, basically in next week, and I will keep you posted.
Yeah. Thank you very much. Thanks, everybody.
Thanks.